everyone. Now, this is question number two that we will discuss. And we have seen the problem number one, and I thought you have understood all the solution and all the steps. Now, this is question number two. If you remember, we have already solved this question when there is external force not applied. And we have solved with respect to center of mass frame. Fine. But here in this question, the situation got changed. Now external force is applied in outward direction. Fine. The two situation may be possible here if external force is applied inward direction and if external force is applied in outward direction. These are the two situations. Always remember when the force is applied, external force is applied in outward direction. So how the maximum extension and compression in the spring during the motion, this is what we're supposed to calculate. So this is one of the finest problem. Let's discuss about the solution. So here we can say this is the situation of the problem and external force. Always remember whenever a force is applied, so we better to think every steps with respect to NLM. Fine. So with respect to NLM, if you are talking about what is a common acceleration? So common acceleration, this is a common acceleration F external upon M total. So it would be F upon 3M. Fine. This is F external. It will be acting on it. In fact, common acceleration we can say of center of mass. Now, since with respect to center of mass, if we are observing M1 and M2, we have to apply pseudo force. So let's quickly see. These are the situation with respect to center of mass. I have applied pseudo force because here my frame is center of mass. Since center of mass is accelerating, hence apply pseudo force. Fine. Hence we apply pseudo force. So here you can see pseudo force. And this is the pseudo force on 2M, and this is the pseudo force on M. It got applied. Now here you can see that F upon 2F by 3, and here F by 3, it got the value of pseudo force. Now, next important thing is if it is spring, this is a natural position, natural length, and so the velocity will be zero of both of the end. And when it got extended up to the maximum extension, once again velocity will be zero. So this concept we will be using with respect to center of mass. So here you can see, like with respect to center of mass, if you are talking about, so initially, initially the velocity is zero, and since force is acting on it, F by 3, that will that will extend the spring in such a way that the final velocity will be zero. Fine. Let's say extension is x1 and here the extension is x2. These forces will bring the spring extension in such a way that the final velocity will be zero. And since the masses are different, hence the extension will be also different. So here we can say the maximum extension in a string. This is the natural position. So what is the maximum extension? Let's say the maximum extension with respect to the natural position is x1 and x2. Because this is a natural length, and with respect to natural length, this is extension x1 and x2. So we can say uh, now here, let's apply now force, reference frame, like center of mass, everything. Now, for the sake of extension, we will apply work, power, and energy. Fine. Work, power, energy. We basically work energy theorem we will apply from this chapter, work, power, energy. Fine. So once we apply work, power, energy to here, you can see for the sake of pseudo force. Now here you can check for the sake of pseudo force, the force it has extension, and this is external force. The extension is x2. Fine. So if we apply, so we can see pseudo force work force into x1 and work external f x2. Now the spring initial extension was 0. That's why spring work done is equal to negative of potential. We can say minus half kx square, and extension is x1 plus x2 because final extension is x1 plus x2. This is important. Fine. And the initially and finally the kinetic energy will be 0. So once we solve this expression, so what we got, this is a very interesting result. We can say once we have taken common, so x1 plus x2 is comes out to be 0. X1, x2 comes out to be 0. This is a natural length. Means while motion, spring cannot compress beyond natural length for the sake of the external force. And x1, x2, this is a maximum extension whose value is 2f by 3k. Fine. So here you can see this line is important. During the motion, it will never compressed, never compressed. Why? Because this is the maximum. This is maximum compression. We can say. Miss, this is a natural length. Natural length h1 h2 was 0. Miss, during motion, once you apply the external force outward direction, the minimum, or we can say maximum compression will be 0. Means there's no compression going to be take place, and the maximum extension is 2f by 3k. So I thought this problem will going to give you very good thinking mechanism, and with respect to center of mass, how we have solved. Now we have, this is the second question. I thought previous question once we have done, we have not taken then any external force to how we have solved. So these two problem will give you enough experience. You can attempt this type of question very comfortably. And always remember only NLM and work, power, energy. These two chapter concept will at least bring you at least 10 marks in advance. So please do practice. I will keep posting different problems like that, and keep watching, and the future belongs to you if you have just managed your rank in advance. Till then, take care. Have a nice time.